10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
One satellite just pushed space-based connectivity into a new era. BlueBird 6 didn't just reach orbit. It redefined scale, ambition, and execution in low Earth orbit. With the largest communications array ever deployed and the heaviest commercial payload flown by India's most powerful rocket, this mission quietly answered a question many doubted. Can ordinary smartphones truly connect directly to space? This video breaks down how it happened, why it matters, and what it teaches us about the future. BlueBird 6 stands out because it was designed around a single, bold idea. Scale solves problems that complexity cannot. Built by AST SpaceMobile, the satellite carries a communications array measuring nearly 2,400 square feet, 223 square meters. That makes it the largest antenna structure ever unfurled in low Earth orbit, surpassing all previous records by a wide margin. This size is not cosmetic. Connecting directly to everyday smartphones is fundamentally difficult. Phones are designed to talk to nearby cell towers using limited power and small internal antennas. Signals traveling hundreds of kilometers from space arrive extremely weakly. Instead of forcing phones to transmit more power or redesigning devices, AST SpaceMobile took a different approach. Make the satellite's receiving and transmitting surface dramatically larger and more sensitive. Before BlueBird 6, the company launched 5 operational satellites, BlueBirds 1 through 5, in 2024. Each of those carried arrays measuring 693 square feet, 64.4 square meters, already the largest in orbit at the time. BlueBird 6 represents a generational leap, not an incremental upgrade. Its array covers more than 3 times the area, enabling stronger links, wider coverage, and improved signal quality without changing user devices. Deploying a structure of this scale in orbit introduces major engineering challenges. Large deployable systems must unfold with precise timing and tension. Any misalignment, incomplete deployment, or mechanical resistance could compromise the mission. The satellite also had to maintain structural stability while minimizing mass, since every kilogram affects launch performance. At approximately 13,450 pounds, 6,100 kilograms, BlueBird 6 became a heavyweight among low Earth orbit satellites. That mass reflects not only the antenna but also reinforced support structures, power systems, and onboard electronics required to manage such a large communication surface. India's LVM-3 steps onto the global stage. Getting BlueBird 6 into orbit was a challenge of equal importance. The satellite launched aboard India's LVM-3, lifting off from the Satish Dhawan Space Center on December 24th and reaching orbit just 15.5 minutes later. The satellite was deployed at an altitude of roughly 324 miles, 521 kilometers, exactly as planned. This mission marked the 9th overall flight of the LVM-3, a 3-stage rocket standing 143 feet, 43.5 meters, tall. Since its debut in December 2014, the vehicle has maintained a 100% success rate, a crucial factor for commercial customers entrusting valuable payloads. What made this launch exceptional was the payload mass. At 6,100 kilograms, BlueBird 6 became the heaviest payload the LVM-3 has ever delivered to low Earth orbit, according to the Indian Space Research Organization. Carrying such a heavy satellite requires precise trajectory planning, controlled acceleration, and tight structural margins throughout ascent. Heavy payload launches place different demands on rockets compared to lighter missions. Engines must operate efficiently across longer burn durations. Guidance systems must compensate for mass distribution, and separation events must occur under stricter conditions. The LVM-3 handled all of these without deviation, reinforcing confidence in its performance envelope. This flight also reflects a broader shift. Historically, India's heavy-lift rockets focused on national programs. Launching a next-generation commercial satellite built outside India signals growing integration into the global launch market. Reliability, not publicity, drives commercial trust, and this mission delivered reliability from liftoff to deployment. The successful launch showed that the LVM-3 is not only capable of reaching orbit, but of doing so with demanding, high-mass, commercially critical payloads. That capability matters as satellite designs grow larger and more complex. Equally important is timing. As launch demand increases worldwide, operators seek dependable alternatives that can deliver precision and schedule confidence. This mission quietly positioned India as a serious option for future heavy commercial launches. BlueBird 6 matters because it moves direct to smartphone connectivity from concept to implementation. AST SpaceMobile is building a constellation designed to provide broadband service directly to standard smartphones, without external antennas or modified devices. This approach integrates satellite connectivity into existing mobile ecosystems rather than creating separate systems. The satellite's massive antenna allows it to generate and steer multiple communication beams, tracking users across wide geographic regions. Instead of relying on dense constellations of small satellites, this architecture emphasizes fewer, highly capable spacecraft with expansive coverage footprints. This design choice carries strategic advantages. Larger satellites reduce the number needed for meaningful coverage, simplify network coordination, and increase per-satellite capacity. BlueBird 6 serves as the first next-generation platform demonstrating that strategy at full scale. The implications extend beyond technical performance. Direct-to-smartphone connectivity reshapes how coverage is defined. Remote areas, maritime regions, and locations lacking traditional infrastructure can be reached without deploying new ground equipment. In practical terms, this expands access rather than replacing existing networks. Competition in this space is growing, but what distinguishes this mission is demonstrated capability. A satellite of this size reaching orbit successfully changes timelines, regulatory discussions, and partnership confidence. It reduces uncertainty around deployment risk, which often slows emerging technologies more than technical limitations. The mission also highlights a broader lesson about progress in space systems. Breakthroughs increasingly emerge from integration rather than isolated innovation. BlueBird 6 succeeded because satellite design, launch capability, and network planning matured simultaneously. Rather than introducing an entirely new device category, this system leverages what billions of people already carry in their pockets. That choice lowers adoption barriers and accelerates potential impact. It also shortens the path from testing to everyday use, because consumers don't need to change behavior or upgrade hardware. BlueBird 6 represents a turning point built on execution rather than promises. It proved that massive deployable antennas can operate successfully in low Earth orbit. It demonstrated that India's LVM-3 rocket can deliver the heaviest commercial payload in its history with precision. And it showed that direct-to-smartphone satellite connectivity is moving from ambition to infrastructure. What changed with this mission is confidence. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. And don't forget to leave a comment below. Thank you for watching, and see you next time.